Download this code from codegive.com, link in the description below. OK, let's delve into common mistakes made when adopting functional programming, FP, principles in Java, inspired by the teachings and insights of Brian Vermeer. We'll cover these common pitfalls, explain the underlying concepts, provide code examples, and discuss how to avoid them. Introduction: Functional programming in Java. Functional programming, at its core, is a programming paradigm that emphasizes immutability, pure functions, and avoiding side effects. It treats computation as the evaluation of mathematical functions and avoids state changes and mutable data. While Java is primarily an object-oriented language, the introduction of lambda expressions and the Stream API in Java 8 made functional programming techniques significantly easier and more accessible. Brian Vermeer, a well-known Java advocate, often highlights the importance of understanding the nuances of FP in Java to avoid common mistakes that can lead to less efficient, less readable, and more error-prone code. This tutorial aims to address those common mistakes. Key concepts: immutability. Data should not be modified after creation. Instead of changing existing objects, create new ones with the desired modifications. Pure functions. Functions that always return the same output for the same input and have no side effects, i.e., they don't modify external state, perform I/O, or throw exceptions unexpectedly. First-class functions. Functions can be treated as data, passed as arguments to other functions, returned as values from functions, and stored in data structures. Lambda expressions enable this in Java. Higher-order functions. Functions that take other functions as arguments or return functions as results. Map, filter, and reduce in the Stream API are examples. Referential transparency. An expression can be replaced with its value without changing the behavior of the program. This is closely tied to pure functions and immutability. Side effects. Actions that modify state outside the function's scope, like modifying a global variable, printing to the console, writing to a file, or updating a database. FP aims to minimize or eliminate side effects. Declarative style. Focusing on what you want to achieve rather than how to achieve it. Stream API promotes a declarative style. Common mistakes and how to avoid them, with Brian Vermeer inspired insights. 1 mistake: overusing streams, hammer syndrome. Description. Just because you can use a stream doesn't mean you should. Sometimes, a simple loop is more readable and efficient. Overusing streams, especially for trivial tasks, can lead to unnecessary overhead and reduced clarity. This is especially true when your functional code becomes excessively complex and nested streams become unreadable. Code example: inefficient stream usage. Why it's a mistake. Creating a stream involves object creation and pipeline setup, which incurs overhead. Find first on a large stream can be slower than an equivalent break statement in a loop if the target element is found early on. How to avoid it. Consider the complexity of the task. If it's a simple iteration or search, a basic loop might be more readable and performant. Stream API is best for processing large datasets or performing complex transformations. Always profile your code if performance is critical. 2 mistake: abusing for each for side effects, impure functions. Description. For each is a terminal operation in the Stream API intended primarily for consuming the elements of a stream, not for performing complex logic or mutating external state. Using for each to modify variables outside its scope violates the principle of pure functions and can lead to unpredictable behavior and difficult debugging. Brian Vermeer often emphasizes that for each should primarily be used for tasks like printing to the console or simple logging, not for core business logic. Asterisk code example, incorrect for each usage. Asterisk why it's a mistake. Asterisk modifying even numbers within the for each loop is a side effect. It makes the code harder to reason about and test. It violates the principle of immutability. Asterisk how to avoid it. Asterisk use filter and collect to create a new collection with the desired elements. This version uses filter to select even numbers and collect to create a new list containing only the even numbers. It's a pure function and avoids side effects. 3 mistake, mutating state within streams. Asterisk description. Asterisk similar to the for each issue, mutating state, especially shared state, within a stream pipeline is a recipe for disaster. This can lead to race conditions, unpredictable results, and difficult to debug code, especially in parallel streams. Brian Vermeer often cautions against any form of state modification inside stream operations. Asterisk code example, incorrect state mutation. Asterisk why it's a mistake. Asterisk some 0 is being modified within the for each loop, which is a side effect. This becomes even more problematic when using parallel streams, as multiple threads could be trying to update some 0 simultaneously, leading to incorrect results. Asterisk how to avoid it. Asterisk use reduce or collect to aggregate values without mutating external state. This uses reduce to calculate the sum in a functional way. The reduce operation takes an initial value, 0 in this case, and a function that combines the accumulated value with the next element in the stream. 4 mistake, ignoring immutability. Asterisk description. Asterisk modifying objects after they've been created violates the principle of immutability. This can lead to unexpected behavior, especially in concurrent environments. While Java doesn't enforce immutability by default, it's a crucial concept in FP. Asterisk code example, mutable object. Asterisk why it's a mistake. Asterisk the person object is mutable because its name can be changed after creation. Asterisk how to avoid it. Asterisk create immutable classes by making fields final and providing no setter methods. If you need to modify the object, create a new object with the updated values. The immutable person class is now immutable. The withName method returns a new immutable person object with the updated name, leaving the original object unchanged. Using records is the simplest way to make an immutable class. 5 mistake, not understanding laziness of streams. Asterisk description. Asterisk stream operations are often lazy. Intermediate operations, like filter, map, sorted, are not executed until a terminal operation, like collect, for each, count, is invoked. Not understanding this can lead to unexpected behavior, especially if you're expecting intermediate results to be evaluated immediately. Brian Vermeer often emphasizes the importance of knowing when stream operations are actually executed to optimize performance. Asterisk code example, lazy evaluation. Asterisk why it's a mistake. Asterisk the filtering and mapping messages are only printed when the terminal operation for each is executed. If you were expecting them to be printed as each element is processed, you might be surprised. Asterisk how to understand it. Asterisk remember that intermediate operations are chained together and only executed when a terminal operation triggers the evaluation of the entire pipeline. You can use a terminal operation like peek, primarily for debugging, to observe the intermediate values without consuming the stream. Peek allows you to inspect the stream's elements at any point in the pipeline without consuming the stream. 6 mistake, excessive parallelism. Asterisk description. Asterisk using parallel stream doesn't automatically make your code faster. Parallelism introduces overhead, thread creation, context switching, Synchronization. If the task is small or the overhead of parallelism outweighs the benefits, it can actually slow down your code. Asterisk code example, parallelism overhead. Asterisk why it's a mistake. Asterisk for small data sets, the overhead of creating and managing threads in a parallel stream can be greater than the time saved by parallel processing. Asterisk how to avoid it. Asterisk use parallel stream only when you have a large dataset and computationally intensive operations. Profile your code to determine if parallelism actually improves performance. Consider the number of cores available on the machine. Be especially careful when the stream operations are I/O bound, as parallelism may not help much in that scenario. 7. Mistake, difficulty in debugging streams. Asterisk description. Asterisk debugging complex stream pipelines can be more challenging than debugging traditional imperative code. The lazy evaluation and chaining of operations can make it difficult to trace the flow of data and identify the source of errors. Asterisk code example, complex stream. Asterisk why it's a mistake. Asterisk if the result is not what you expect, it's not immediately clear which step in the pipeline is causing the issue. Asterisk how to avoid it. Asterisk use peak, asterisk insert peak, operations at various points in the pipeline to inspect the intermediate values. Asterisk break down the pipeline. Asterisk decompose the complex stream into smaller, more manageable streams. Asterisk logging. Asterisk add logging statements within lambda expressions to track the values being processed. Asterisk debugging tools. Asterisk use the debugger in your IDE to step through the stream operations and examine the data at each step. Asterisk testing. Asterisk write unit tests to verify the behavior of each step in the stream pipeline. Here's an example of using peak for debugging. 8. Mistake, misusing optional. Asterisk description. Asterisk optional is a container object that may or may not contain a non-null value. Its purpose is to handle situations where a value might be absent and to avoid null pointer exception s. However, optional can be misused, leading to code that is more verbose and less readable. Asterisk code example, overuse of optional. Asterisk why it's a mistake. Asterisk the if name is present, check and the subsequent name get call are often unnecessary. Optional provides more concise and functional ways to handle the presence or absence of a value. Asterisk how to avoid it. Asterisk use or else get, asterisk provide a default value to use if the optional is empty. Asterisk use or else throw, asterisk throw an exception if the optional is empty. Asterisk use map, asterisk transform the value inside the optional if it is present. Asterisk use flat map, asterisk chain optional operations together. Asterisk avoid using optional as fields in classes. Asterisk this is generally discouraged, as it adds complexity and can lead to confusion. Here's how to use or else map and or else throw. 9. Mistake, not handling exceptions correctly. Asterisk description. Asterisk functional programming principles encourage pure functions that don't throw exceptions as part of their normal operation. When dealing with Java's checked exceptions, which force you to handle exceptions, this can become challenging. Brian Vermeer often discusses strategies for dealing with exceptions in a functional style to keep your code clean and maintainable. Asterisk code example, handling exceptions in streams. Asterisk why it's a mistake. Asterisk directly mapping functions that throw checked or unchecked exceptions into a stream can lead to unhandled exceptions and break the functional flow. This can lead to unexpected program termination. Asterisk how to avoid it. Asterisk catch and wrap. Asterisk catch exceptions within the mapping function and wrap them in a custom exception or an optional if appropriate. Asterisk create a wrapper function. Asterisk create a helper function that handles the exception and returns a result. Use libraries. Consider using libraries like Vavra or Cyclops that provide more robust exception handling mechanisms for functional programming. Here's an example using a wrapper function and optional. Summary and conclusion. Functional programming in Java offers numerous benefits, including improved code readability, testability, and maintainability. However, it's crucial to understand the underlying principles and avoid common mistakes. By following the advice outlined above, inspired by Brian Vermeer's teachings, you can write more effective and robust functional code in Java. Remember to be mindful of stream usage. Don't overuse them for simple tasks. Avoid side effects. Keep functions pure. Embrace immutability. Use immutable data structures. Understand laziness. Know when stream operations are executed. Be cautious with parallelism. Profile your code to ensure it improves performance. Handle exceptions gracefully. Avoid breaking the functional flow. Use optionals correctly. Don't overuse or misuse optional. Practice debugging techniques. Debug complex stream operations. By consciously avoiding these pitfalls, you'll be well on your way to mastering functional programming techniques in Java. Good luck! Remember to always profile and test your code to ensure that your changes are actually providing the benefits that functional programming promises.